Hello guys, welcome to the Learn to Dab channel. So first of all, thank you very much for the likes you gave in my first video. Many of you have messaged me on LinkedIn and Telegram, and we talked a lot about flash swaps. And so because you guys really liked the video, I'm gonna be preparing a next one probably around next month, which will go through like JavaScript and Solidity code for running this flash swaps bot between Uniswap and SushiSwap. But first, I prepared this video for you. It's going to be a little bit more technical. It takes some concepts from the very interesting EIP, which is the EIP 3156, which basically talks about flash loans and flash mintable tokens. And we're going to be creating an example of a flash mintable wrapped ETH. Wrapped ETH is basically ERC20 token that is always equal to 1 ETH. And yeah, guys, I hope you really like this technical content. We're going to be using Hardhat, Ether.js, TypeScript, and setting up this flash mintable Solidity contracts. And if you guys like this type of videos, please show that you like this kind of content by leaving a like in this video, subscribe to the channel, and let's go to the code. All right, guys, so I just created a new Solidity Hardhat project using a very cool repo called Solidity template. I'll leave the link here in the video description. So it's a very cool template. It uses basically Hardhat, which is a TypeScript framework for creating and working with Solidity smart contracts. So it's very cool because it bootstraps a lot of things. Some of them we're not going to be using in this video, like unit testing and like coverage, but it's very good like to have it working with linter, prettier, and everything set up for start working in smart contracts. So first, I'm going to create a contract called flash wrapped ether Solidity. So we're going to declare the file. We are going to be using Solidity 047 for the smart contract. Declare the contract flash wrapped ETH. It's going to be a very simple contract actually. So I'm basically going to use OpenZeppelin's ERC20, add a few functions that work similar way that the wrapped ether token works. However, we're going to be adding an extra function called probably flash mint. And this flash mint function will be responsible by allowing people externally owned accounts to call and ask to mint an amount of tokens, but not necessarily send ether. And that way they can mint tokens as long as they burn these tokens back in the same transaction. We can optionally turn on a fee. I will show how you can do all of that. So first of all, we're going to import the libraries that we're going to be using, which is basically, oh, by the way, we already have OpenZeppelin installed. You can do like yarn add Zeppelin / contracts. In our case, actually haven't installed packages. So okay, I'm just going to skip this part. Okay, so I just installed OpenZeppelin all packages here in the project. So I'm going to import OpenZeppelin / contracts token ERC20 Solidity, which is the ERC20 contract from OpenZeppelin. We are also going to be using a library called SafeMath, which is for doing safe arithmetic operations in Solidity, so we don't have like overflow and underflow errors. Oops. Okay. So first of all, we're going to use SafeMath for Uwin256. Also, I just have a small typo here. Oops. Okay, OpenZeppelin. All right. Okay, so we're also going to add a receive function, which is default function we can add. So we allow our smart contract to receive ether by sending like a transaction with no transaction data. Also, we're going to declare a few more functions, which is the deposit function, which is also actually a public payable function. We're going to call deposit every time someone sends ETH, so the person could just send ETH to our contract or can invoke deposit function. We also have the withdraw function, which is external, not payable. And withdraw, we will receive the Uwin256 amount, which is basically the amount of wrapped ETH to be converted back to Ethereum, to ETH tokens, to ETH currency. All right. So on deposit, we will basically execute mint, which is a private function coming. Oh, first we have to inherit ERC20 token is gonna be called a flash wrapped ETH F or ETH symbol. Okay, so we're basically gonna mint to message sender. So the first parameter is who we are going to be minting tokens to, and the second parameter is message value. So we are basically here minting to the message sender the amount of tokens, the amount of ETH sent to the deposit function. Okay, so withdraw. In withdraw, we are going to first execute burn. So we burn from message sender the amount of tokens requests, the amount of ETH requests to be converted back. So basically burn here in OpenZeppelin, it basically reverts if the sender doesn't have enough wrapped ETH to be burned. So here we don't need to add any additional requirement, because if the sender doesn't have enough wrapped ETH to be burning to convert back to ETH, OpenZeppelin ERC20 contract already has that logic to revert. So after burning, we're basically gonna execute a transfer to message sender with the amount of ETH requested. Okay, so this is the basic setup of the Flash wrap ETH contract. It's pretty simple. It basically is inheriting from OpenZeppelin ERC20. We add a field function to deposit ETH, so we deposit ETH and receive wrap ETH back, and we can withdraw our ETH by burning some wrap ETH tokens. This is not the exact code that wrap ETH runs, but it's the same logic, it's the same mechanism. So what is different in this Flash wrap ETH version is that now we're going to add a function called flash mint. So I'm going to declare the function. It's going to be external. Okay, guys. So actually, before we continue writing the flash mint function, we're going to come here. We're going to create a new folder called interfaces, and then we will create a I flash minter interface. So basically, this interface represents an address, another smart contract created by the flash mint consumer, which basically this contract needs to implement this interface to be able to make a flash lint and make some code execution and do things with the flash minted tokens. So you're going to declare the file here. This is also using the 0.7.4 Solidity version. Oops, not contract, it's actually the interface I flash minter, which has basically one function, it's one on flash mint. Note that this implementation is a little bit different from the EIP flash loan and flash minting implementation. It's more simple, so like the flash minting and flash loans EIP, it's much more complete and has like more examples. So this is basically just for having a quick demonstration in the video, but if you want to like get a better understanding of other type like flash loans, flash minting, and how like more deep examples in the code, please check out. I will also drop the repo here in the video description. Okay, so this on flash mint, it's an external function, and oh, actually, I think I have it copied here. Oops, let me just. Yeah. Okay, so this is the iFlashMint interface. The onFlashMint function has 3 parameters. One is the sender. So the smart contract knows who has sent the message to the flash wrapped ETH token. This is good for making some verifications, or in case like you want to have a flash minter contract that only allows a certain address, like a controller address, to send flash mint calls. The amount of tokens being minted, and a byte array of data that is basically some parameters that the function would you would pass along to the onFlashMint function. So with the interface declared here, we're going to come back to the FlashWrapIf token contract. We are going to import this interface from /interfaces iflashminter solidity. So okay, so basically we're gonna get the parameters here in the FlashMint function, which is the recipient, which is basically the contract. The smart contract is going to be receiving these FlashMinted tokens, the amount of tokens to be minted, and the bytes array that can be optionally passed along to send data to the FlashMinter contract. Okay. All right. So we are going to basically declare the iflashminter using the FlashMinter interface. FlashMinter equals minter recipient, which is the recipient smart contract received the tokens. Okay, so now here is where the magic happens basically. So we are going to mint tokens, wrap ETH tokens to the recipient with his amount requested. So we can see that we did something very similar in the deposit function, but instead we take the ETH value that the FlashMinter is sending to the contract to mint an equal amount of FlashWrapIf tokens. So here we are minting an arbitrary amount, can be any amount of FlashWrapIf tokens, and then after we mint, we're gonna call the FlashMinter. So the FlashMinter contract, we're gonna expect he has the onFlashMint function implemented. Okay, so with the onFlashMint function, we pass onFlashMint. We pass the sender, which is the message sender, the Ethereum account or another smart contract that is sending this message to the FlashWrapIf, the amount of tokens being minted, and the cal data, the data that the contract can execute, and that is being passed. Okay, so all right. So here the FlashMinter will execute his own FlashMint. Oops, I have an error here. Not found or not unique. Just a second. Oh, sorry guys, I had forgot to save the FlashMinter interface file, so that's why like it was showing that this interface didn't exist, but now I just saved the file and it's all good. Okay, so I execute the onFlashMint function, and after the execution is finished, so basically here I am minting an amount of FlashWrapIf tokens to the FlashMinter contract. I execute and expect the contract to have this onFlashMint function implemented. That's why we created iflashminter interface. And after the function execute is over, we basically do the burn internal ERC20 function. So we burn from the recipient an equal amount of tokens that he has minted basically. So we expect that after the function execution ends, so we mint in some FlashWrapIf. He can make some trades like sell for DAI, like make anything with these tokens. And after the execution finishes, we do the burn function. And if the FlashMinter doesn't have enough FlashWrapIf and the contract balance, basically the FlashMint function execution will revert, and everything from here is invalid. So because when a transaction reverts, when a transaction comes to the miner to be mined and reverts, it basically is invalid, and it's like it has never happened in the blockchain. So that's why this is safe, and that's why we can mint tokens freely even without having collateral ETH being received. Okay, so we basically have everything implemented here in the FlashWrapIf contract. We could have definitely added some more advanced stuff, like adding a small fee. So we required that the FlashMinter burns some more FlashWrapIf tokens that he minted. So it creates some sort of incentive, so we have like a deflationary supply. It can be interesting in some use cases, but in this one, we're gonna keep it more simple. So I will show you later at my deploy script in Hardhat, which basically makes some interactions between the flash wrap if and the flash minter. And it becomes simpler without the fee implemented. But right now, we're gonna create the flash minter contract, which is another very simple contract, which is basically the smart contract that a developer that is running a bot off-chain would like to create to interact with this flash mint token of this wrap if token. So we're gonna create a new contract here, which is the flash minter solidity. So we declare the file. Solidity pragma line. Oops. Okay, so now we create the contract flash minter. Okay, so first we're gonna import the iFlash minter interface. Our contract is gonna inherit from it, so it enforces the interface implementation, the iFlash minter. This contract is gonna be a very short and simple. So first of all, we have the constructor. Here in the constructor, we're gonna declare two state variables. One is we're going to record the total borrowed amount, which is like, oops, borrowed. Basically the amount of tokens flash minted by this smart contract. And we also going to declare the address public, immutable. Sorry, it's going to be private, immutable controller, which is the smart contract controller. We don't need to do something more, a little bit bigger, like honorable, because it has very simple logic. So we're gonna declare the controller here, the constructor, set up the controller, which is basically gonna be the contract owner and the one allowed to be making flash mint calls. So we have here the flash mint. Okay, so the flash mint function is exactly this function executed here by the flash if contract. One more thing, guys, that I forgot to implement is that we are also going to be passing down to the constructor the flash wrap if token address, and we declare here as a private immutable state var that's going to be used in some verifications here in the flash mint function. So as we can see here in the interface, the flash mint received three parameters, which we're going to implement here, which are the sender address, the amount of tokens being minted, and the byte array of data that can be passed, that is passed option. It can be used optionally. We're not going to use the data parameter here in that case, but we could use it. So we're gonna make two condition checks, very simple, which we require the message sender, the contract signing this function call is the flash wrapped if contract, otherwise we revert. We also going to require that the sender, which means the account or contract initiating the transaction, is our actual controller, which is defined in the constructor. So with these two conditions, we have a little bit more safety to make sure that only this transaction is only coming from our wallet and something that we intend to do, you know? So, okay, so we have these two conditions. Now we're gonna basically, on flash mint, we're gonna take the total borrowed variable and sum up the amount minted. So this contract is very simple. We just basically have make sure that the message is coming from the flash wrap if contract, that the sender is the controller, and we save the amount minted. So I can show you very soon in the example, the flash mint working and this contract basically saving the amount of tokens that we are minting. Okay, guys, so we are almost done the Solidity part. We just need to add the override, the override keyword here, because we are inheriting from the interface. I'm also going to run, it's a problem here. Oh, okay, so, there is a small typo here. Okay, so we add the override, just fix the small typo. Oh, I'm also going to run this Solidity template comes with many predefined scripts. One very interesting is called Yarn Prettier and Yarn Lint, which is basically uses like Solhint and Prettier for fixing contract code styling and linting patterns. So you just run Yarn Prettier, and it automatically will fix and set our code like pretty nicely to look much better to read and enforce the linting pattern. Okay, guys, so that's pretty much it for the smart contract section, the Solidity section. Now I'm going to show you a little bit on the Hardhat deploy script that I've written. And if this script, we're going to play around and use some cool features from Hardhat and type chain, which is basically a very nice CLI that allows us to have type definitions from Solidity smart contracts used on TypeScript and makes our life much easier to interact with smart contracts. Okay, guys, so let's try together from scratch the deploy script. Our intention here is to basically deploy the flash wrap ETH token. Then we deploy the flash minter contract, and we're gonna simulate a flash mint and have it recorded in the total borrowed state var in the flash minter contract. So first, let me run yarn type chain, which is a command from this template. I think I've already run it, but it will compile our smart contracts and generate here the type chain folder TypeScript definition, so we can use it and have a better typing in our client, so we can have like get to know what functions a smart contract have, and it makes like our life much easier for debugging and writing this interacting with smart contracts. So I'm gonna import from /type chain. We're gonna make a few imports here. We're gonna import the type definition of the flash minter factory from the flash wrap ETH factory. Okay, so first we're gonna create flash mint const flash minter equals to await ethers. Ethers dot get contract factory, and we pass flash minter. Sorry guys. First, we're going to do the flash wrap ETH, which is going to be equals await get contract factory flash wrap ETH as flash factory. So we give the correct typing here. So then, by giving this flash wrap ETH factory type to the result of this promise, TypeScript knows that, okay, this is of type flash wrap factory, and then we can go and declare flash wrap ETH, which is the instance deployed of the flash wrap ETH factory. We're going to deploy. When we deploy, TypeScript automatically knows that this is of type flash wrap ETH, and with this, thanks to type chain, awesome too, we can do like flash wrap ETH, and we have like all the type definitions correctly, so we know like the functions, the contract functions it has, like balance off, no. Okay, so like flash mint, and basically we have, it makes our life much easier. Okay, so we just deploy the flash wrap ETH. We're gonna console log the address so we can know where it has been deployed. Deploy to, and we get here the flash wrap ETH dot address. Yes. So now we are going to declare flash minter factory, which is very similar to the previous lines. Await ethers get contract factory flash minter. And we change the type here to as flash minter factory. So same thing, we get the type definition injected into our instance. So we do like flash minter equals to await flash minter deploy. And here we already know that because thanks to type chain, we need to give the flash wrap if address to deploy as it's defined here in the constructor of the flash minter. So we deploy and we pass flash wrap if dot address as the parameter. Okay, guys. So we are also going to console log flash minter. Oops. Just fix that. Okay. Flash minter deployed to flash minter dot address. Okay, cool. So here in our deploy script, we already have deployed the flash wrap if token and the flash minter token. So now we are gonna play with the flash mint. Okay, guys. So I have this basic script running. If I can already run, like, you can do like npx hardhat run -- network hardhat, which is our development local blockchain, and execute the deploy.ts script. And if everything works well, we're gonna have the flash wrap if and the flash minter deployed to our local blockchain. Okay, all right. So we have like the flash wrap if token deployed to if we're save. Let me save and run again. Hardhat run -- network hardhat, and we run the deploy script. Okay, so all right. So we have the flash wrap if deployed. The flash minter deployed. So every time I run this script, the Hardhat creates a new blockchain, local blockchain. So that's why I got the same address twice. But now we're gonna add a few lines that is gonna make everything much more fun. So we're gonna declare a new transaction, and this transaction we're gonna call the. So basically, we are calling from our local Hardhat Ethereum account, and for the first address of our list of accounts, you can check our list of accounts here in Hardhat, but basically you're running npx Hardhat accounts. It's a default script coming with this template and many or others. So we have the whole list of accounts we have running locally. Okay, guys. So, all right. So basically, we're gonna make a transaction from our main account to the flash wrap if contract, which we're gonna call the flash mint function. And the flash mint function, as we can see in the type definition here from type chain, it requires 3 parameters, which we define the smart contract. Okay, so which are the recipient, the amount of tokens to be minted, and the optional data parameter. Okay, so it's actually not optional, it's optional in your contract, like in your flash minter contract, but here we need to pass at least an empty array, which is what I'm gonna do. But you can add some data parameters to make your contract like more complex. Okay, so basically the recipient is going to be the flash minter.address, which is our flash minter contract. We're gonna mint an amount of, I'm just gonna use the ethers.js, which is ethers.js, by the way, is the library that Hardhat uses, and I find it much better than web3.js in my opinion. So we're gonna use the utils.parse ether. So with this function, we can input, for example, 100 to mint 100 flash wrapped if tokens. This function basically brings the number 100 to and adds 18 decimals, which is used by most ERC20 tokens and is used by Ether. And we also need to pass the third parameter, which is an empty array in this case. Okay, so we have our tx object initiated. We're gonna await tx.wait. So we wait for the transaction to be executed, and basically this is the flash mint call. So also we want to make sure that the flash mint worked. Like if nothing, we can already test with Hardhat, like npx Hardhat run, and we can check if the transaction is passing or reverting. But I'm also going to add a few more lines of code so we can check with the flash minter contract, the total borrowed amount, and make sure everything is working fine. Oh, let me remove this. Okay. And we are going to basically declare the variable here is the amount minted. It's going to be wait. We're going to execute the flash minter function, which is the total borrowed public state var, which as we see, as we've reading together, this total borrowed basically adds up the amount we have minted in the flash wrapped if token contract. Okay, so we execute the total borrowed, and we're going to console log flash minted amount. Oops, put this flash minted amount, and the amount minted. Okay, since this is not a transaction like that is changing state in the blockchain, we don't need to do like await tx that wait, because this is just a getter function. We're not like submitting this transaction to be mined. That way we can just query data from the blockchain. Okay, so now if I execute Hardhat script, we'll see the amount that has been minted by the flash minter contract, and all the pieces interacting together. So okay, as we see here logged in the console, there is the flash wrapped if token address in our Hardhat blockchain, the flash minter deployed address, and the flash minted amount, which is basically 100 in the power of 18, which is like 18 decimals, which means that we just minted 100 flash wrapped if tokens. So this can have a lot of utilities. For example, if the current wrapped if token had some sort of flash mint capability implemented, people wouldn't need to borrow wrapped if from providers like Uniswap, Aave. They could just flash mint directly from the token contract and use it for trades, even without having any collateral. So instead of like depositing Ether to get wrapped ETH, we can temporarily mint an amount of wrapped ETH and use this for trades. This can have very interesting use cases. Of course, this is all very experimental software, and there's a lot of debates in the community because you know, it's different from flash loans, and it might have like some positive points and other negative points. So it's still something that I haven't, at least personally, I haven't seen any production projects really using like flash mint and being widely adopted. But it's a very cool and interesting use case. And yeah, I think it's also very nice to like demonstrate it working all together with the Solidity smart contract and the Hardhat. So that's it for the video, guys. I hope it was helpful some way for you. If you like this video and want to see more, please leave the like down below in the YouTube video. Also, thank you very much for all your interactions and likes in my first video. And don't worry, the video on flash loan bot, like showing step by step in the code how to create your flash loan bot, will be coming probably this month. It's probably the next or the other video. And yeah, thank you very much for watching, and I see you guys in the next videos. Bye bye.